Good morning, esteemed guests, and a warm welcome to another enlightening session in our Ag, Water, and Energy Education Series. It is a pleasure to have each of you here today, whether in person or joining us virtually, as we come together to explore the transformative potential of direct air capture technology and its impact on our communities. But before we begin, I want to make a special announcement. We have been joined this morning by the Kern Community College District Chancellor, Dr. Bloomberg. Dr. Bloomberg, thank you for joining us this morning.
Good morning, everybody.
My name is Nicole Parra, Vice President, Community Affairs for California Resources Corporation and Carbon TerraVault. And I'm honored to extend a heartfelt welcome on behalf of the Kern Community College District to today's presentation, which marks an important occasion, offering us the opportunity to delve into the purpose and the goals of the Direct Air Capture Hub project and its significance in Kern County and beyond. Throughout our time together, we'll be privileged to hear from a distinguished lineup of speakers, each bringing their unique expertise to the table. From understanding the fundamentals of DAC technology with Ken Haney, to exploring sustainable practices and innovations with Leslie Matthews. Our discussions promise to be both enlightening and thought-provoking. Additionally, we will have the privilege of gaining insights from Mr. Tunde Duru and Norma Rojas Mora as they shed light on the DAC Hub's project impact and community benefits plan. Their perspectives will undoubtedly deepen our understanding of the environmental, social, and economic dimensions of this initiative. As we move into our panel discussion, expertly moderated by Norma Rojas Mora, we'll have the opportunity to engage with a diverse array of voices, including community leaders like Dee Slade and labor experts and leaders like Alyssa Reed. Together, we'll explore the future of DAC hubs and the crucial role they play in achieving carbon neutrality while ensuring community well-being. I encourage you all to participate. So for those of you here in person, please hold your questions and comments until the end of our session, where we have a dedicated question and answer session. Those online, feel free to put your questions in the Q&A box, and we will answer them during the Q&A session later this morning. Once again, thank you for all of you for your presence and engagement. Let's make today's event an enriching and collaborative experience for all. Thank you. Yes, you may applaud. This was very tough doing this right now. All right, thank you. So Ken Haney, let's give a warm welcome to Ken Haney, Strategic Advisor in Carbon Management at California Resources Corporation and Carbon TerraVault. Ken.
Throw it out there. Good morning. Thank you, Nicole. Welcome, everybody. I think I recognize most of the faces here. So hopefully I'll be able to talk about a few things that you haven't all heard from me before. So welcome. So the first thing I'm going to talk about is why we need DAC. What is the value of DAC and what is it really giving us? So to start that discussion, let's talk about the energy across the planet. So since I'm searching for a word here. Since the energy revolution at the turn of the 20th century, look at what the population on the planet has done, all empowered by affordable, reliable energy. We're sitting at 8 billion people now. Problem is, we don't quite yet have enough energy to support that population. We still have about 1 billion people without access to electricity. We still have about 2.5 billion people without access to indoor fuels for cooking. So we're faced with a challenge here. On the one side, we need to reduce our emissions associated with energy. On the other side, we need to expand our energy supply and our energy delivery systems. So it's a tough challenge. And this is what enables and requires technologies like DAC direct air capture, which we're going to talk about today. So this is just one estimate. There's lots of estimates out there about what the energy future looks like, but by 2050, we're going to need, according to this study, we're going to need an extra 45% of energy that we currently have. And if you look at the stacked bar here, you can see a lot of this expansion is driven by either renewables, so solar and wind, but also by natural gas and other fuels. So we may not like fossil fuels. We're getting a bad name around fossil fuels, but fossil fuels are going to be around for a long time, and there's a challenge here, and we need to do our best to transition and get cleaner with those fossil fuels. So switching over to emissions now. So what's the result of all this energy turning it into emissions? So this is a study done by the International Energy Agency a few years back. Worldwide, we emit about 32, 35 gigatons of CO2 annually. Okay, so if we, let's see, do we have a pointer here? Don't think we do. If we stay on that current trend, we're going to be up above 40 gigatons. So the goal is not to stay on that current trend. If we stay on what are called stated policy scenarios, which is a couple of years ago, the policies stated by the different governments across the world, we would stay flat. The goal, according to the Paris Accord, is to reduce, and you can see that sustainable development scenario takes us down to about 10 gigatons out in 2050. So that's the goal, and that's to stick with the Paris Accord we've all heard about. How do we get there? Improvements in efficiency, expansion of renewable energy, and then fuel switching and carbon capture and storage. Those are kind of the three pillars of how we get these emissions reductions that we're after. So looking at this at a very high level and how this all fits together, and I am going to get to DAC, believe it or not, but I think this background is good. If you look at the middle line, the black line there, that's a kind of a theoretical pathway to us getting to 1.5 degrees warming. We have to get down to zero emissions by about 2050, and then we're going to have to actually go negative out into 2100. So the two other lines, the red line and the blue line, the red line is the actual emissions we'll have and we'll be emitting. So I showed you we're at 35 gigatons now. We need to get that down into the 5 gigaton range. So we need to use all that toolbox of technologies to get us there. But then we also have to follow that blue line, and that's removal. In order to get to 1.5 degrees of warming, we actually have to remove CO2 from the atmosphere and from our point sources of emissions. So this is just kind of a broad view of to get to carbon neutral and then to stay at 1.5 degrees warming, we're going to actually have to pull CO2 out of the air, whether it be by direct air capture or natural land usage, by planting trees, however you want to look at it. So just real quick, the four pillars of technology that we see coming to bear here, low carbon electricity, so that's renewables, battery power. So why do we need batteries? Electricity from renewables and wind have what they call a capacity factor in the 20 to 25% range. That means over the course of a day, they only deliver for about 20 to 25% of that time. So you've got to be able to overcapacity them and then store that energy to have it available. So batteries are crucially linked with low carbon electricity. Got a long way to go with batteries. Currently, their duration is not too long and they're very expensive. Clean hydrogen is another path. I won't get into that. That's a whole other topic in itself. But then carbon sequestration is the other pillar here, and that's what we're going to talk about with direct air capture. So I want to differentiate real quick what we call carbon capture and what we call carbon dioxide removal. So carbon capture is when we go into an existing power plant or a steel plant or a cement plant, and we capture those emissions out of the stack of that plant. So we stop those emissions from going into the air. That's carbon capture. Carbon dioxide removal is where direct air capture fits. And that's where we actually capture CO2 out of the atmosphere itself. So big difference here, believe it or not, because the emissions coming out of power plants could be anywhere between 4% and 25% CO2 concentration. The atmosphere is 0.04% CO2 concentration. So big difference in how you engineer and the physics of trying to capture CO2 from a plant versus out of the atmosphere. Okay. So a little bit on direct air capture, and this is pretty generic. We were talking about it earlier. There's a lot of companies doing direct air capture. There's a lot of different technology spins on direct air capture. But generally what we're talking about is pulling air out of the atmosphere with fans, okay? Contacting that air with what we call a sorbent, whether it's a solid sorbent or a liquid sorbent. It absorbs the CO2. We then have to apply heat to that sorbent and CO2 to liberate the CO2 out of it so we get a pure stream of CO2 that we can inject underground. So that's in essence how all of them work. They all have different spins on the technology. Some of them use heat. All of them use power. Some of them use heat. Some of them also use electrochemical type of processes. So we're getting a lot of different spins on direct air capture technology. Geologic sequestration of this CO2 is really the path right now. There's quite a bit of technology and companies out there looking at utilization of CO2 in different products. But for now, really the only viable pathway is storing the CO2 underground. Let's keep going. So direct air capture, what does it look like? What scale do we have to get to? Okay. So to put it in perspective, the largest plant in the world right now is Climeworks plant in Iceland. It's 4,000 tons per year is what it's capturing. Okay. California's goal is to get to 66 million tons per annum per year of capture by 2045. The US goal about 200 million tons. The worldwide goal about 1 billion tons. This is per year. So we're sitting now at the largest plant, 4,000 tons, or yeah, 4,000 tons per annum. So we got a long way to go and a short time to get there. And there's a lot of technology to be developed and to be optimized here. So I don't want to get too deep into this. This is called an abatement curve. But what we're seeing here is the different technologies to abate CO2. Their cost is on the vertical axis, and the amount of emissions that we see them targeting is on the horizontal axis. So if you look for direct air capture, it's way over on the right. So there's a good chunk of emissions we can go after with it, or CO2 that we can go after with it. But it's also the most expensive approach right now. And that's the challenge, okay? Direct air capture is currently on the high end of expense per ton capture. And for obvious reasons, right? You're trying to separate 0.04% of CO2 from air. It's just going to be more expensive than any other process that's out there. So our goal now is to drive that cost down and get it to scale quickly. So how do we do that? Well, the federal government has stepped in with a lot of vision and a lot of foresight, and they're really driving the DAC train probably 10 or 15 years before I expected it to get going. So if you look at the Infrastructure Investment Act of 2022, $1.2 trillion, okay, 62 billion of that went to the DOE for carbon abatement projects. About 3.5 billion of that went into a fund for DAC projects. And we'll talk today about the CalHub project. That's a small piece of that 3.5 billion. We hope to, in our next step, get a larger piece of that 3.5 billion. But right now, the pool is $3.5 billion for direct air capture. Again, that's federal funding. There's other ways to enable DAC, and there's other policy and programs out there to enable direct air capture. This is a few of them here. California has our low carbon fuel standard, where we subsidize low carbon fuels that are used in California. DAC does qualify for the low carbon fuel standard. There's a federal, what they call 45Q credit. So when you store CO2 underground, you're eligible for the federal 45Q credit. It's very significant for direct air capture. It's $180 a ton in the latest version of 45Q regulations. And then there's the voluntary credit market, and that's a little bit more fuzzy. But what the voluntary credit market is Taylor Swift decides to go to Japan and get sushi in her private jet. So she has a carbon footprint by doing that, whether it's 100,000 tons of CO2 emitted. She can go back to one of our DAC hubs and say, hey, look, I will pay you $500 a ton for 6 months for your carbon credits to offset what I just did with my private jet. So that's how the blockchain and that's how the voluntary credit market works. You have the Microsofts, the Googles, the Apples, all wanting to offset their carbon footprint and call themselves carbon neutral. So they can do that by this voluntary credit market. So it's another enabler for direct air capture and technologies to decarbonize. Oops, last slide, and then I'll talk a little bit about the CalHub project. The DAC and general carbon capture in general have quite a few upsides, and this is just a few of them. Depending on the technology, we can get some local air quality improvements out of them. On top of removing CO2 and reducing the global warming impacts, there's also some criteria pollutant benefits that we can get. And again, it's technology dependent. It's going to have to be evaluated case by case. Local economic activity is obviously a huge one. This is not coding. This is not somebody in Silicon Valley coding. This is boots on the ground, infrastructure creation, and high level engineering, procurement, and construction projects. So job creation and preservation, same thing. We have the skill sets in this county for sure, based on the energy and ag backdrops that support this type of activity, and they're going to get us this type of deliverables. I think that's all I have on general DAC, and now we're going to talk a little bit about CalHub. So, do we want questions now or at the end of the thing? Okay. All right. So let's talk about CalHub. So CalHub is the consortium that we put together to go ahead and apply for those federal dollars, and we're successful. And this is just a couple of propaganda displays here. So we made it onto the cover of Carbon Capture magazine. So that was good. And then we've got some more publicity and some other Carbon Herald and other journal types. Oops. So this is the press conference in Taft. So in August of last year, the consortium was awarded the federal funding to do these studies. So this was just a picture from that press conference. So here's where I'll talk a little bit about CalHub. First of all, first thing I'd like to mention is that this is a collaboration of over 40 partners. This is a big coordination, a big undertaking, and just a great example of the community coming together. And if you look down at the bottom here, you can see industry, community, tribes, government, national labs, academia, labor, workforce, and some of you are here today. Met a couple of labor guys this morning. CRC has been engaged with the California building trades for a long time. But our technology partners, Climeworks and Avnos, those are the two DAC technology providers. I'd start talking about individual, but I don't want to because I'll miss some and don't want to go down that path. So suffice to say that this is a team effort, and we've got a great team together that worked on this project and continues to support and work on this project. We're in the process of actually finalizing the government contracts now, so we expect funding to happen here in the next 30 to 60 days. Few details around the project. This is really the first step of a vision to take a direct air capture hub across California. You can see over on the right, San Joaquin Valley and Kern County are really the first step, and we'd like to go beyond that. What this DOE funding covers is front-end engineering design studies. So we will be doing feed studies on two major DAC technologies in two of our CRC oil fields. Also, we'll do a feed study on a pipeline, and there'll be other feed studies around plant integration. There's two stages to this study. The first stage is a small scale plants. So there'll be two 50,000 ton per annum plants. And then the second stage is 1 million tons per annum. So one will be 500, the other will be 500 plus. So it's not only a staged evaluation, it's also in two different technologies, two different DAC technologies in the hub. Let's see what else. If you think about direct air capture and pulling CO2 out of the atmosphere to try to reduce the CO2, if you're using not clean power and heat sources to do that, it kind of defeats the purpose of direct air capture, right? If we're using coal-fired power plants to power the DAC plant, it kind of, and we're putting more CO2 from the coal power plant into the air than we're taking out with the DAC plant, it defeats the purpose. So we need to focus on clean energy sources when we're talking about direct air capture, and CalHub has focused on and partnered with multiple companies around clean energy sources for heat, for power, and also for water. I promised Tunde I'd mention TA3. So TA2's government funding is about $12 million, and we'll match that, and the total budget for the project is about $24 million. That's really the first step here. The second step is to actually go after the big funding for the project. And that can be up to $500 million. And that's what they'll call the TA3 application. So once we finish the work here on this, what we call TA2 application, then we'll be ready to apply for the TA3 application, which is where the significant dollars to actually fund and build these projects comes in. Just going to talk real briefly about community benefits, because I know Tunde is going to cover it a little heavier, but we've actually worked on this project for a long time. We started back in probably February of 2022 when we started pulling the consortium together. We started talking about community benefits as early as the summer of 2022. We didn't actually put in our application for the project until I believe we submitted in March of 2023. So we had a good year's head start on working on this before the application was even due. So this has been a long project. It's been a lot of coordination and a lot of hard work by a lot of people. I think this is my last slide. So I just wanted to give you a kind of a flavor for the community benefits side of this and how the Department of Energy has framed the community benefits. So really four areas they ask you to address in your community benefits plan: community and labor engagement, investing in the workforce, diversity, equity, inclusion, and accessibility, DEIA, and then Justice 40. So this is a nice slide that I stole from Nicole. It kind of breaks down for this project we're doing here, this 2-year project of CalHub. We have it broken into 4 phases. And just to give you an example on the community and labor engagement, first phase is about awareness. Second phase is about negotiating with the communities. Third phase is about executing. And then fourth phase is about updating. And this will carry on. So I talked about TA3 and going for the next application after this one. This community benefits plan will flow through that, and we'll really start getting teeth and a lot of funding once we get to that next TA3 application. I think that's it. That's it. I probably took too much time, but thank everybody for their patience. Thank you.
Great job, Mr. Ken Haney. And before I introduce our next speaker, I wanted to, as Ken mentioned, we do have the president of the Kern Inyo Mono Building Trades with us here today, Stephen Gomez. And I also wanted to partner not only in the consortium, but on many things with California Resources Corporation. Also wanted to congratulate Mr. Bruno Solomon with National Cement. He's here with us today. And as you all know, in Kern County, that was a big win. They just won a big $400 million $500 million decarbonization from the DOE. And all of us from the consortium, many of us were involved in partnering with them with the community benefits. So that's exciting. So at this time, I'd like to introduce Leslie Matthews, no stranger to Kern County. We had her out in Taft and Buttonwillow for some of the local county and EPA hearings. And she got to meet a lot of people from the community, especially the CREL team here at KCCD, the California Renewable Energy Lab. And she got to spend time here at Cal State Bakersfield and meeting with community leaders. So Leslie, here's the mic. Thank you for joining us today.
Thanks, everyone. It is great to be back. It feels like Ken was just saying about the weather where I live is rainy and cold. So it always feels like a nice vacation to come here. Even when I was here in February, I was like, oh, this is so nice. This is lovely. So like Nicole said, my name is Leslie Matthews. I work with an organization, a company called Climeworks. We are based in Switzerland, but we have facilities operating in Iceland and then hopefully elsewhere. And so, and just to correct Ken, we are commissioning our second facility in Iceland today, like this week, and that has a nameplate capacity of 36,000 tons of CO2 capture. So that's exciting. That's very, very exciting. And I'll talk a little bit more about that as we go along here. Oops. Oh, maybe you have to queue up the next slides. I'm not sure. Yeah, it is. Oh, thanks. So we'll just, yeah, we'll just get the slides going here. Just hang tight. And thanks to all the folks who are online. I know that Sonia was telling me that it's exam time. That was like a long time in my past, remembering exams in April and May. So I appreciate people who are here today and all those folks who are online. I hope you're able to catch this this webinar at a more relaxed time for you. I know. Take a moment of meditation. There we go. Oh, so we've done the intro. There's my gigantic face on the screen. We're good. Okay. So I won't repeat too much about what Ken has already started, but I think he's given me a really good segue into talking about Climeworks. And so Climeworks is like one of many organizations, companies that are trying to advance direct air capture. The difference with us is that we were the first in the world to have a commercially functioning facility. So the facility in Iceland, the 4,000 tons per year, we are actually able to generate carbon credits that we can sell on the voluntary market. So first to commercial, but there are lots of other technology providers nipping at our heels, and that's a good thing. So we'll talk a little bit more about other technology providers, but I'm just going to be giving you guys sort of the perspective from Climeworks as one of the technology providers. So this is all stuff that you can find on the Climeworks website. Lots of like great videos and stuff on there. We've got quite a bit of experience in direct air capture. So we were started as a company in 2009. So although we call ourselves a startup company, that's like 15 years of experience or so, going on 16. The two founders, started this technology and started the company as a spinoff from their PhD work in inventing this technology. The technology is really, it's not so much new as it is a reorganization of the pots and pans that you might find in a processing facility. The capture and use of CO2 has been going on for a very, very long time. So, we have, someone in the cement or sector here. So, putting its CO2 into cement. putting CO2 into your Coca-Cola. That's how we actually first started capturing CO2 and selling it at a food grade in 2017 in Switzerland. And since then, we've advanced to realizing a different business model, which is to capture CO2 that can be sold as credits. And there's a lot of companies that are really interested in buying these credits. I think I read a statistic that something like 80% of global emissions are under some kind of net zero commitment from the people who generate those those emissions. And so you can see where folks are looking around, having made these like net zero CO2 targets, but are kind of looking around, kind of going, how do we do this? And how do we do this in a credible and verifiable way? So an interesting thing about us in terms of like, we'll talk a little bit about scaling up. So, we started off with a very, very small facility in like a back alley somewhere in Zurich, to capture CO2 to sell to Coca-Cola. Since then, we started the 4,000 tons per year facility called Orca. It's in Iceland. And then about 10 times greater in size, 36,000 tons per year, Mammoth in Orca or in Iceland as well. And then from there, we're looking at like 10 times scale up as we go through iterations of and evolve the technology. So that's where it comes to the scaling up will actually make sense because we've proven that it already has made sense. So how does this technology actually work? And this is like where all the engineers are going to cringe because I'm not an engineer. And so when I describe it, when I ask them to kind of tell me how it works, and then I say, oh, let me just translate this into an analogy. So basically what happens is there's a container, this sort of like cube-like container. The pictures I'm going to show you look more like shipping containers, but this is where the technology is going to go in terms of being able to make it more modular and stackable. So like a fan, kind of like your vacuum cleaner, will suck the air in, and the air is laden with CO2. It is adsorbed. So adsorbing is when you get like sucked in by a solid particle. So there's particles, adsorption particles on this sort of like, I'm going to call it flypaper. So vacuum flypaper. It sticks to the flypaper, and then when we reach a saturation point, all of these like the fan turns off and this closes, so it kind of creates a vacuum, and it heats up to about 100 degrees centigrade, which is like 212 degrees Fahrenheit, and that helps to release the CO2. And then the CO2 is carried off to the main processing facility where it's processed and then sent off for storage. So if we're next to a storage facility, it would go like right into be injected. Otherwise, it would have to go on like, a pipeline or a truck or things like that. So so this is where it gets a bit cringy when I say, oh, so what you're saying is like, this is a vacuum cleaner, it's a flypaper, and then it's a sauna. And then and then they all kind of like, yeah, I guess so. But that's how I remember it being like a little bit more simple. And so it goes through these cycles of, so it sucks the air in, it closes, the CO2 drops out, and then it reopens. And that just cycles 24/7 until we have to replace the sorbent. So the sorbent is the flypaper. Forgot that detail. Let's see. So this is just to give you an idea of kind of like the inputs and the outputs of, and I know Ken showed you this, but this is what it looks like at the first facility in Iceland. So we're very, very lucky. The government of Iceland invited us there to have this facility. So we had access to their geothermal power. So Iceland is almost, I think it's 100% geothermal power. So we were able to co-locate with a geothermal plant. So had access to their power and their heat. We do the capture. So this is the capture unit in the middle. And then we're right next to a partner. We partner with organizations or companies that do the sequestration. So we don't do the storage ourselves. We would partner with a service provider that does the storage, and that's Carbfix. Carbfix is also looking at operating, if they're not already, in the States in the Pacific Northwest. And so we are also very lucky. We just have some facility pipe to pipe us over to the Carbfix facility, and then it's permanently stored underground. It is greater than like 800 meters underground. And so that's a very important thing to remember in terms of like safety of storage. I know there's lots of concerns about the safety of storage and potential leakage. Very low probability of leakage because of where you look in the geological layers. There's certain criteria that have to be met, like nowhere near a drinking water source. you don't want it near another, source where it could leak, so abandoned wells, things like that would have to be plugged so that they don't become a source of leakage. And it also has to drill down below something called a cap rock. So there's like a seal that goes over top of where you would inject. So you drill it down through that cap rock into the zone of injection. And that can be anywhere from 800 to 800 meters to 2 kilometers below the surface. So it's quite a distance below. And in this case, this is also the same as the Pacific Northwest, not the same as around Kern County. In Iceland, what happens is it goes into a basaltic rock formation and it actually turns to rock. The CO2 turns to rock. In around Kern County, if I'm not mistaken, it doesn't turn into rock, but it stays as something called like a supercritical CO2 state. So it's somewhere between like a gas and a fluid, but also it's sort of like if you think of it as a sponge, it just sort of like migrates into the little pockets of the sponge, and that's where it stays sequestered permanently. So like I said, we've got, facilities already operating in Iceland, and we've made announcements on developing facilities in the United States. So when Ken was talking about the different levels of funding, we were also, fortunate enough to receive sort of the highest level of funding to look at building or to participate in a carbon capture hub in Southwest Louisiana. So we're doing that project, and certain thresholds have to be met before we can actually get to construction. But with the idea that we would build out that hub to at least 1 million tons of CO2 capture per year. And that could go, beyond that. And then working in CalHub on the, pre-feasibility, or not pre-feasibility, the front-end engineering design. I'll talk a little bit about that. We're also working with partners in North Dakota, looking at a potential site in Canada, Norway, and Kenya. So the great thing about this is that there's certain pockets of the world that have the geological formations below that make the storage very attractive, and that's where you want to be looking at putting in direct air capture. Other criteria have to be met, but that's probably the most important one, that you want it permanently stored. So a little bit about the project at CalHub, or our part of the project at CalHub. So there's a lot of stuff on this slide. I was hoping that you guys would actually get a copy of the slide so you can, take this away and, read it on the weekend over your coffee. I know that you'll do that. But just some really key takeaways in terms of what the hub is. So like the hub is like this kind of nebulous thing, but I think of it as like the middle of the hub being the storage, and then there's spokes that go out from it in the different infrastructure. So you'd have, different direct air capture providers. Maybe you would also have the carbon capture on like the combustion of like at a power plant and things like that. And all of these things go to the storage. So and you can build that hub out as you've got the infrastructure in place. So by no means is this hub only going to be limited to, say, like Climeworks and then the other technology provider is Avnos. It could bring in other technologies that, are relevant to this area. But I can only talk about the one that, we're doing. So obviously Kern County, we are hopefully going to get some announcement on the funding. They tell us any day now, any week now. But what we'll be able to accomplish, and I think Ken touched on this already, is like the front-end engineering design, and then the planning for the hub that can store at least 50,000 kilotons. It's probably going to be, more than that. So that, or sorry, not the hub, like our facility that would store at least 50,000 or capture and store at least 50,000 kilotons. And then with the idea that you can scale that up to 1 million tons. And so why the work that we're doing in other parts of the States is really important is that we can leverage that to make this one, more effective and to really prove out that scale can actually happen. And then hopefully what we would do is, knowing that we can get up to the 1 million tons, we can replicate that across areas of the US where the geological storage is relevant. So we're looking at 2 different sites right now. Our site would be at the Kern Front oil field. One of the great assets that Kern County has is that you have these sites that have already been disturbed by oil and gas. We don't need a pristine site to put our direct air capture facility, so we can certainly leverage sites that maybe have already been disturbed, and not having to perhaps compromise other land uses. So that's really great that we can locate in the oil field. And then Avnos would be at the Elk Hills oil field. I think you all know that from like the EPA hearings. We also look at we need a source of low to zero sources of heat and electricity. So that's going to be one of the things that we're investigating in our the front end engineering design is where could we get, you know, perhaps waste heat, or where could we generate heat from perhaps renewable energy? Where could we also get water? So water is obviously a huge challenge in this area. We don't need like fresh, pristine water. So looking at using produced water from the oil and gas field, the oil field here has a lot of produced water with it. So potentially using that as our water source, which is really exciting. And then of course we have a means to store it underground permanently. And we're also working on supporting and delivering our aspects of the community benefits plan. So I'll talk a little bit about the main one is really like workforce development. So this is like I let the communications folks loose on this one. So this would be like the layout of this is, I think this is Mammoth in Iceland, but it would be if it were laid on over like a landscape that looks like Bakersfield or Mars. It's just, I was like, okay, I'm sure that will be relevant to some, yeah. So you can see that like the capture units, they sort of look like stacked shipping containers. They will look a little bit different. Like this is what we called our generation 2 technology. And what we're looking right now is our generation 3 technology. So it's just a different iteration where we can use, we can really be efficient with the landscape and the footprint and still get up to 1 million tons. So the landscape would be about like probably about 60 acres to get to about 1 million tons, 60 to 80 acres. So by no means do we need to like expand exponentially or, you know, incrementally the footprint to get to the 1 million tons per year. So that's what conceivably it will look like. So it looks like kind of like an Amazon fulfillment, you know, center. That's the main processing unit, and then our shipping containers. And why I think that Kern County, there's, you know, some really unique opportunities and some challenges here. And the challenges are exactly what we're going to be working on in the front end engineering design. So of course, renewable energy, like Ken said, we don't want to be capturing CO2 and then kind of negating what we've just done by using energy that also creates, you know, CO2 emissions. So we use renewable energy, but of course we don't want to be competing for those renewable electrons as more demands for renewable energy are coming into California. So what we focus on doing is like providing additional renewable energy through maybe a virtual power purchase agreement or some other way of like incenting like a new solar farm or a new wind farm, or, you know, geothermal is like, you know, really ideal because it works kind of 24/7. But what we don't want to be doing is driving up the costs of electricity in the local area by competing for those green electrons. And we know that there's going to be just a huge demand. It's exploding, certainly in this area with, you know, the use of AI and data centers. And those are huge energy sources or huge energy demands as well. So that's one thing we gotta solve that. And then of course the energy infrastructure, building that out, like transmission lines, like you know, if we don't have it co-located with the energy source, it's got to come from somewhere. Water usage, obviously, a really important challenge in this area. So like I said, looking at using produced water so that we, again, we don't want to be using drinking water or water that is prioritized for agricultural, because doesn't make any sense. And then the economic impact, we really want to understand how this could have a benefit for the local economy and the workforce. And we know that like people here, they know oil and gas, they know processing, they know industrial jobs. And this is really just like, it's an industrial processing facility. It just happens to process CO2. It's nothing, you know, terribly new. So we know that there are, you know, transferable and adaptable skills that we can get from Kern County if we can link up with the right folks to understand who's available, who's interested, you know, what kind of training do we need to offer to bridge any gap that might be there. So why, you know, scaling this essential technology, why we think it really works in Kern County is that, you know, we know that decarbonization. This is going to be complementary to any plans to decarbonize in the US. California is obviously like at the forefront of that. Kern County, I mean, like everything that I've seen about the folks that we've been working with in Kern County is that that folks here are really interested in being early adopters and leading this industry. It's also, I like to call it like the carbon value chain. So, you know, you all know how to get value out of carbon when you take oil out of the ground. This is just simply an extension of like realizing that carbon has value for the use of in, you know, cement and, you know, Coca-Cola, but it also has use when we inject it back in the ground and can permanently sequester it because people want to buy those carbon credits. And the government in the US has been very proactive about, you know, offering, I guess like income tax credits for that. So that's where our business model comes in. We can store that, we can store it, we can get the money in the voluntary market, we can get the money from the US government in order to get these credits for the next, I think they're available for like 10 or 12 years. But it has value, carbon has value. And then scaling the right way. So we know that we can validate and prove that we've stored the carbon. We have a verifiable process that's done by a third party. And that's it aligns with the Science-Based Target Initiative, if you're familiar with that. But that's an initiative that a lot of companies have signed on to, that they will use a scientific way of validating the carbon that has been stored so that they can get credit for that and apply that to their net zero targets. Oh, look at that. I'm at the end of it. So I guess the one thing I wanted to make sure that people understood is that so Ken talked about the difference between carbon capture at a point source versus direct air capture, and like the different applications of that. Direct air capture is also different than carbon offsets. And so just want to make that, you know, distinguishment. None of these things are like better than others. They all have different applications. And really, like if you're looking at getting to net zero, you want to be looking at every single tool in your toolkit to do that. So we certainly see direct air capture as like complementary to carbon capture. It's certainly complementary to like reducing emissions, you know, at the front end. So in no way, you know, does this replace or compete or outcompete other technologies? It's like one thing that you want to have in your toolkit when you're looking at net zero. That's it.
Thank you. And in addition to all of the very important people in the room, I just wanted to acknowledge that we hear that there's some West Kern folks from Taft and Buttonwillow online. And I wanted to say a special thank you to Les Clark III, not the first, not Mayday, Mayday, but the third, the district administrator for the West Side Recreation and Park District, who are huge partners to all of the work we're doing and all of the community members. I know Devin Dougherty was here from Taft College, the Taft Foundation, folks out in, you know, McKittrick, Derby Acres, and Buttonwillow, and all of the West Side communities. We have enjoyed partnering with you. We want to continue, you know, and that's why I stole Tara O'Neill from West Side Park Recreation District to ensure that the community out in West Kern has a voice at the table. And because these projects in Elk Hills, we're your neighbors, and we need to make sure that you and your voices are heard 24/7. And I do hear Les Clark's voice 24/7. It's a good voice. It's a good voice. At this time, I'm honored to welcome Norma Rojas Mora, Executive Director of Government Relations Development for Bakersfield College, and my good friend and partner, Tunde Daru. Tunde is the principal at Project Development Solutions. And I'll tell you, I don't think 2 years ago he thought he'd be involved with community benefit plans and partnering with companies and helping them to understand. And he's my engineer when I'm trying to talk about how projects are developed. And he's just a genius. And I'm so happy. And we're very lucky to have someone like Tunde here in Kern County. So with that, Norma, here's the mic. And I understand you're going to be introducing the panel. Or no, you guys are speaking.
We're speaking first, and then we'll introduce.
So let me get out here. Perfect.
Good morning, everyone. Or good after. Well, it's still morning. So again, thank you so much, Nicole, for that introduction. As you're hearing, we're going to be spending quite a bit of time talking about the community benefits plan in general, as well as sharing details about the Cal DAC Hub Community Benefits Plan, which really will be the blueprint for a high road transition to a diversified, clean energy economy. And really, it can be a model for projects, not just in our region, but throughout the nation. So again, looking at how Kern County can lead the work. The community benefits process is an opportunity for us to elevate populations that will be most affected by the project, which includes the areas of Taft, as Nicole said. I think this morning someone said, oh, Nicole's going to be at Kern CCD. She has now is being known as Miss Taft. So it's not Nicole Parra, it's Miss Taft, but which is wonderful. Also the community of Shafter and Southeast Bakersfield. So to assist with the implementation of the plan, we've partnered not just with CRC, but with wonderful partners such as Tunde, who helped develop the community benefits plan for the DAC Hub, but also with a lot of our community and labor partners. And I just want you to know that this partnership and this growth of bringing people to the table is going to continue to grow. We are in the planning aspects of this grant, and I want to emphasize that this is a planning grant. So it really is an opportunity for people to be at the table to help shape how we're going to move forward as a community as we evaluate the community benefits for the DAC Hub. So before we talk about the specifics, we're going to rewind a bit. And I know you've heard it from every speaker, but a community benefits plan, or a CBP, because we love acronyms at the Kern Community College District, is a document that outlines how a specific climate mitigation project engages community, creates quality jobs, and supports vulnerable and/or frontline communities. Remember, all federal funding opportunities are requiring applicants to develop a CBP plan. So to go more in depth as to what the DAC Hub CBP process is, I will turn it over to Tunde.
So thank you very much, Norma, and good morning, everyone. So Tunde, there is the name, and as Nicole said, a year or 2 years ago, I didn't imagine I'll be this engrossed in community benefits plan. So as Ken said, in 2022, I got introduced to this, and we started looking at how to strategize and respond to the DAC Hub application that the DOE was going to issue, and community benefits plan was something that we looked at. And it's been an exciting journey. So what I'll do is just give you a background on how this works, what the government expects, and what drives it. So in Ken's presentation, he spoke about the bipartisan infrastructure law, which is the bill, and the Inflation Reduction Act, IRA. So those are the two laws that drive kind of the need for community benefits plans. So what the government is doing is, we're going to give 64 billion out there, but as we give you 64 billion, we want you to look at these communities and invest in them. So there are areas of investment that they're looking at, and which is kind of how you integrate renewable and mitigate climate change. So these laws are driven to kind of mitigate climate change projects. There are climate change mitigation projects whereby as you invest in those technologies like Climeworks, we want to understand the impact and how you engage the community on doing this. And also as you do that, we want to also make sure you are creating quality jobs in doing that. And then also we want to make sure that your investment there's no community left behind in a nutshell. So that's what they're looking at, and that's why we have community benefits plan. And to go deeper, I think Ken mentioned it in his presentation, and there are 4 main policy areas in a community benefits plan. One has to do with community engagement and labor engagement. So on the community and labor engagement, what the idea is we don't want to fund this project and the community doesn't want the project. So we want to make sure there's meaningful engagement with the community as you go through the different phases of the project. As Ken said, that we're currently going to start the FEED process, front-end engineering and design, And as you go through that process, we want to make sure you are engaging meaningfully with the community, getting their input, getting their feedback, having community meetings with them, making sure they understand the project, making sure they're aware of the impact and the different phases of the project, and getting their input and incorporating it in that. The other aspect of the policy focus is, in addition to community and labor engagement, Ken mentioned about CRC already having a relationship with the building trades. So that's a huge plus because the Biden administration wants quality jobs and wants labor engagement in the community development plans. The second aspect of policy focus area is investing in American jobs. So we want to make sure in America, as we develop the technologies for the future, as we come up with this climate mitigation project, we're also developing the workforce that is able to do this. And that is a key component of that. And Kern County is in a unique position to offer that because we're an energy community. And there's a lot of correlation and transfer of skills within these industrial projects. Next one is DEIA, which is another focus area, which is diversity, equity, inclusion, and accessibility. And what the Biden administration is looking at is that, okay, we're going to give you money. We don't want any minority group left behind as we give you money. And we want to make sure you engage minorities from a job standpoint. People from minority backgrounds are given job opportunities on this project. Minority-owned businesses have opportunities to participate in this business and in this project, and we'll make sure you do so. So as part of the community benefits plan, there's a kind of scorecard when you submit your application. The community benefits plan you put together would earn up to 10% or 20% of your score, depending on the kind of projects you're working on. And the last one is Justice 40. So Justice 40 is a tricky one because it kind of wants 40% of the benefits of the project to be felt or to be effective on disadvantaged communities. So I'm going to talk about that in a little more detail. So when you talk about Justice 40, there are 8 primary focus areas that the Biden administration wants you to pay attention to when you look at disinvested communities. So working on this slide, I noticed that the word disadvantaged was used before, and I changed it because that is not an acceptable word with Nicole and Norma. So, so these communities are not disadvantaged, they're just disinvested. So kind of cleaned it up a bit, but the DOE uses disadvantaged, but we're here in Kern, we use disinvested. And so those disinvested communities, when you look at the Enviro map, it's a mapping tool, and there are many socio-economic factors that impact these communities, poverty rate, unemployment, environmental exposure, and they are ranked. So we've looked at communities in Kern County that Norma has mentioned, Nicole has mentioned, Taft, Shafter, and East Bakersfield are disinvested communities. So there are 8 areas that the Justice 40 wants you to focus on. One, you can categorize these focus areas into 2. Things they want you to decrease and things they want you to increase. Definitely you want to decrease energy burden and environmental burden in these communities. Then you want to increase kind of access to clean energy adoption, energy resilience. So like in Irving, if there is a PSPS event, that power safety shutdown, I don't know what PG&E calls it. You want them to have energy resilience. You want them to have energy when they need it, like any other person does in Seven Oaks or Southwest Bakersfield. Then you want an increase in energy enterprise. We want more jobs that have to do with clean energy to be from these communities. We want people to know about solar panel washing and whatnot that they can use. And then the other one is clean job pipeline, democratization of energy, and access to low-cost capital. So those are kind of the 8 focus areas of Justice 40. So finally, let's look at the DAC and CalORB CBP objectives. So Ken in the slide mentioned kind of what it did, the 4 phases, and I've kind of summarized what we're looking at for the DAC, and I'll just touch on each one of them in the interest of time. So for community and labor engagement, our key focus is to have what we call a community benefits agreement in with those three communities, Shafter, Taft, and East Bakersfield. We don't have a form of the agreement, but it's going to be a process. We're going to engage the community in meaningful conversations. We're going to understand what they need. We're going to implement that, and we're going to come to an agreement of the minds on what the best form of agreement is for each community or for the three communities. And then diversity, equity, and inclusion. I think CLC has gone a long way in incorporating kind of minority businesses in their business as usual. And we're going to expand that with this project. And in expanding that, we're going to do it in two ways. We're going to make sure that from these disadvantaged communities, there are opportunities for job employment for people from these disadvantaged communities and opportunities for businesses that are minority businesses to be part of this project. For the investing in quality workforce or Invest in America workforce is kind of two focus areas. The first area is making sure we can reskill, upskill workers. So specifically for Kern County, where we want to transition from conventional energy to a clean energy, to a cleaner energy economy, that is of significant importance to us. And then the second aspect is making sure there is union awareness. As I said in the previous slides, when you talk about community and labor engagement, there's a keen focus on union, ensuring union jobs are there, good quality jobs. The last leg, which is Justice 40, has to do with creating a JEDI model, which is Jobs Economic Development Impact Model. And we'll be working with NREL to do that and Cal State Bakersfield to create a model. And what we want to understand is what is the impact of the Cal Hub on Kern County from an economic standpoint, from a job creation standpoint, and utilizing that and using that to drive our economy as we go forward. So at this point, I'm going to turn it over to Norma to talk about our CBP partners. Thank you.
Thank you, Tunde. So as was mentioned earlier, we've been working on this process for over 2 years. So the list of partners that you see are, as it states, preliminary CalHub CBP partners. These are people that came to the table at the initial submission of our application. So the technical and project management will be provided through Kern CCD and Project Development Solutions. So we'll be working with Tunde. We're going to be providing community education. We have community and labor engagement, workforce development partners, and of course, our DEIA partners. But again, this is just the initial list of partners that came to the table when we first initiated this process. And it's been a long process, right? We've been saying since January, oh, we're going to have the contract in place and we're going to be able to roll this out, but that hasn't happened. We're waiting any day now, as both Leslie and Ken said. We hope to have that contract in place so that we can begin rolling out meetings and rolling out what our process is going to be for engagement. So I know I said it earlier, but I want to re-emphasize what our ask is, and part of this is come to the table, come learn more. We're going to be having a lot of meetings. And you've already seen Nicole out in the communities a lot, engaging people about what this process is and what the opportunities are. So I think with that, we wanted to transition, and I'll hand it over to Nicole so that we can go even more in detail with some of the partners that have come to the table and answer some specific questions for you.
Well, thank you, Norma. And there were a couple people I know left off the screen. I'm looking at my building trades folks. Don't be mad. That was probably just an oversight because we are remembering working with the building trades to ensure when I was working with the IBW Brian Holt that folks were on the Community Advisory Council and will be doing outreach directly with all of the trades. So that's one of the partners that wasn't listed there, but is when we say partners, we mean these are the folks that will be Kern CCD will be contracting with to begin executing the T2. At the same time, while we're executing the T2, we're also going to be preparing for the T3, as Ken Haney mentioned. And so we're going to be building a bigger consortium to ensure that we're ready for the next round of DAC. And we will be partnering with Cal State University Bakersfield to help lead the community benefits plan and for the next phase. So we're going to kind of be doing this together. But as we're preparing for T3, we want to make sure that we're even doubling our efforts on consortium folks and making sure everyone's at the table. So those are great presentations. Tunde and Norma, thank you so much. Up next is our panel discussion featuring our community leaders and of course, Leslie Matthews, who's now part of our community, our family. And we have Dee Slade, the Executive Director for the African American Network of Kern County. But as many of you know, she wears many hats and is our local Kern County historian and always keeps me educated every day. Alyssa Reed, Executive Secretary of the Kern Inyo-Mono County's Building and Construction Trades. And I can't wait for her to talk about this partnership CRC will be doing with the building trades. And then Leslie Matthews, Senior Stakeholder Engagement Manager for Climeworks. Again, I'm looking forward to this discussion that will be moderated by Norma Rojas Mora. Thank you.
Thank you, Nicole. So we're going to jump right in. Leslie, can you please share your insights on the role of DAC hubs in achieving carbon neutrality? Additionally, what opportunities and challenges do you foresee in scaling up DAC technology?
Yeah, so I guess the role of DAC, Ken touched on it. What we've seen is that there's really no path to 1.5 degrees or staying below 1.5 degrees of warming without some kind of removal of legacy CO2 emissions. And so that's where direct air capture comes in. And I said at the end of my talk, it's complementary to everything. So DAC makes sense when, companies and governments are looking at net zero, but they're also putting in other, policies and tools to not only reduce the emissions that they're producing today, but that they're also investing in DAC, direct air capture, to get rid of emissions that they may not be able to reduce. So some of they're called like scope 3 emissions, the sort of like their induced emissions through the services or, products that they buy or make. But also, being able to, remove the legacy emissions. So there's a path to getting to sort of like, I guess, neutral, but we need to get below neutral. We need to get to zero in terms of CO2 emissions so that we can stay below the 1.5 degrees. And that 1.5 degrees, of course, just so we're all on the same page, that's where like the modeling shows that we would have the more devastating consequences of global warming and climate change occur. And we're already at that point. So we want to get back to something more manageable, something more predictable in terms of the effects of climate change. And so that's where DAC fits into the whole. It's like one tool in the toolbox. And I think the second part was about like the scaling, the challenges with scaling, opportunities and challenges. So in terms of like the challenges, of course, that's what we're going to be looking at with the funding that we've gotten. So, accessing a renewable source of energy such that we're not, in any way competing for renewable energy from like residential users or municipalities, not wanting to drive up any of those costs. The second part is making sure that we can use and reuse water that is not, being used for drinking water. So looking at, the use of produced water. So we think those things are potentially achievable. Obviously, we have to do some more work on how it's going to be relevant to Kern County. And I think some of the opportunities in Kern County is that we have such obviously great partners. I mean, I just feel so relieved every time I come here. It's just so, it's very much like stepping into a project that is very like well organized. Because one of the challenges that we have seen in other areas and through like, focus group work that third parties have done is that there's a real lack of like understanding and awareness about carbon management. And I think when all of this information comes at people, they can really sort of like pull away and the acceptance of new and change can become a bit of a barrier if we haven't done this in a way that engages people and in a way that it's accessible to understand what this technology is and how it fits into the whole carbon management picture. Even using things like carbon management, people are probably like, what? Like, what is that? How does that fit into my understanding of, energy and oil and gas and how, how the world works? So, making sure that we are mindful and also engaging at like a very foundational level to build people's awareness. And that will help us, build acceptance for, the new and the change that could come, such that it's not in any way threatening to folks, and that they, have an understanding of the different trade-offs.
Thank you for that. Dee, could you elaborate on the significance of community agreements and engagement from your perspective as such a iconic community leader?
Thank you. My perspective is this. First, engagement. You have to have messengers that the community or residents are comfortable with. And that is what we're doing. We've been doing this in Kern County for years. And briefly, 1995, for 3 days at CSUB, under the first Hispanic president, Arsenega, we put forth the vision for 2020. We also later put forth the vision for 2030. That 2020 vision was led by, and she's still alive, Cheryl Borbage. And in that vision was energy, that vision for the community to sustain itself, the vision for the future of oil and the future of water. Because as you know, we utilize water that comes from the north, and it also goes all the way down to the south, Southern California. We also focus on transportation. You're hearing a lot now about the high-speed rail, and I'm excited that I was a part of that design. We sent a gentleman to Japan to look at how the high-speed rail worked. And guess what? Ian, South African, but a resident here in Kern County, brought the draft, the pictures, and the idea back. So what I'm looking at from that perspective, we engage with the community for the future of the city of Bakersfield and the county of Kern. And guess what? Our retired Congressman Bill Thomas was part of that vision also. So when he retired, guess what? Funding came to Kern County, and I believe all of you use that funding every day. The West Park Freeway, the new freeways that dump you from one end to going towards Las Vegas. It'll take you fast forward to Main Avenue. So my perspective is engage, educate, make them aware, be an advocate. And from that comes the community benefits plan.
Thank you so much, Ms. Dee. So Alyssa, can you share insights on the current project labor agreement with CRC, the upcoming labor agreements with the Kim Building Trades, and the plans for developing pre-apprenticeship cohorts for the next round of DAC grants?
Yeah, that's a lot, but so as has been mentioned, the Building Trades has been a longtime partner of CRC with a project labor agreement on the maintenance of the existing fields. And that agreement has been very beneficial to the community from a workforce development perspective and providing jobs for the community. We expect these projects coming forward and the new project labor agreements to equally benefit the community in providing good jobs for our members, and good quality jobs, I think, is the thing that we stress when we talk about the trades. It's about the quality of the job that comes with a sustainable wage and benefits and retirements and those things that are so valuable to people throughout their life and allow them to earn a living that supports their families. And so we're really excited about bringing those jobs to the trades and to Kern County. The other piece of that question, our pre-apprenticeship program, We're really excited. Our Building Trades Council has offered a multi-craft core curriculum apprenticeship readiness program for about the last 4 years. But we are super excited to partner with CRC to be able to expand that program and continue to offer that, and to be connected with some of the disinvested communities that are being impacted by this project. So we're reaching out to, in partnership with Nicole, we're reaching out to communities that we have not touched with our program before. And just a little bit about what that program does. That program is an introduction to an apprenticeship program with the trades. So it gives an overview of a variety of different trades, talks about what an apprenticeship program is. And the apprenticeships with the trades are real jobs where people can begin to learn about a trade and go through till they're a journeyman level within that trade and earn while they're going through that program. And so we're really excited to be able to offer that program.
Thank you so much, Alyssa. And that really brings us to the last question, which is quickly for each one of you, what excites you the most about the work you are doing related to this project? And we'll start with Ms.
Oh, I'm excited, the baby boomer. I'm excited to be part of this history that all of you behind me coming forth are going to be a part of. And what I see is good jobs. They're going to be jobs elevated with technology, science. There'll be all sorts of avenues that people can partake. Where I come from, we had entry-level jobs, went into being a maid. And if you wanted to work yourself up, you could be a maitre d' at a restaurant because you had the skills coming from culinary, what you call it today. We called it learning how to work in the kitchen. So what I'm seeing is the future. And I'm so happy to be part of this vision, this journey with CRC. And everywhere I go, I ask the question, have you heard of Carbon? Do you know what Carbon TerraVault is? Do you know anything about CRC? I asked my stylist this week and she said, no, what is it? And I told her, you need to go look at this site. What are you involved in, Miss D? A lot. And so this is what I want to excite everyone, the old, the baby boomer, down to that new one that's in, that just don't know what he or she wants to do. There's a place for them and there's a big opportunity. And guess what? We're going to be on the map again. City of Bakersfield and the county of Kern and California. Oh, yes.
Yeah, oh, that I'm excited too. Yeah, just hearing about that. I guess being in, this area, it's not so new, but it's very new to people trying to explain, carbon management as this like new industry. And I think what excites me is that it's not that new because we can just bring people along from, the jobs that they may want to leave or they may transition from with all the skills. And I think that it's just such a great fit. And that's why I get very excited about, the idea of carbon management, but also doing it in Kern County, because there's just so many things that really fit here in terms of like carbon management and leveraging all of the stuff that folks have built here as an energy, hub. And then the partners that you guys have assembled, like I'm not just, saying this, but working on other projects, I can see how different and how you have already, built up this great consortium of willingness and that's where it sort of like gets into the community and you can turn in from like the energy hub to like the carbon management value chain hub. And that's bringing Bakersfield back on the map and Kern County. So very exciting.
Well, I would have to go back to our apprenticeship readiness program. I think the most exciting thing for us in offering that program is the ability for people to change their lives and to set them on a path for a long-term career with a sustainable income. And, it's an opportunity for people that that really from disinvested communities that didn't really know what they're going to do or don't know what they're going to do. Some people are, struggling to, pay their rent and feed their families. And this opportunity can provide them with a job that's really going to change their lives and change their families' lives for generations to come. And so we're really, really excited to be able to expand that program and continue to offer it.
Thank you. Thank you all so much. Could we have a hand?
Yes, great job.
I know that.
And more to come on the CRC partnership with the building trades. We can't talk about too much now, but this really came out of folks, while we're waiting for grant funding or to include more of the partnerships in future grants. Communities asking now, where can we get involved with the pathways today, Nicole? Where can we, Alyssa? So from local pastors to the Open Door Network to some of the organizations we've been meeting with, what CRC is doing is we're investing to expand and sponsor slots where people can start getting involved in August, getting involved in January. But again, more to come from folks. It'll be the first. It'll be a partnership that's never been done in the state or the country. And so we're excited with the Kern Inyo Mono Building Trades and CRC and Carbon TerraVault to be able to do this together while we're waiting for the other monies. But when we're knocking on doors in Button Willow or Taft or in West Kern or Southeast Bakersfield, people want to know, how can you help us today? Well, we can. That's what we're going to be able to do while we're waiting for the other things. So very excited about that. So as we near, I know we'll probably expand a little bit, Sonia, the questions, but we're going to, feel comfortable if you have questions, folks in the room, to come up and talk in the mic here, or Norma has a mic, and then questions from the folks online. I'm going to ask Tunde and Ken to make their way forward because I'm sure there's going to be some questions for those folks. So Sonia, go ahead. Let's see.
Okay, all right, I have a first question.
Please grab your chairs.
Let me
Grab
see
some
if this
chairs.
is on. Okay, from Jane Thompson, one of my dear friends. She's a very smart engineer. Do private companies decide who credits are sold to, or do they work with the governing or regulatory body? And they put in parentheses, might have missed the answer to this earlier.
Yeah, no problem. So we look at deals with private companies to sell, so we offer a service with our technology, and that we can capture the carbon, verify that it has been permanently stored, and then we generate the credits from that. And so that can be done either like through we do the private validation. And so we would have like a commercial agreement with a company to be able to do that. So like in the EU, we have like a deal with like Lego, for example. So, they have hard to abate carbon dioxide emissions maybe through their supply chain or through like the products that they sell. And so they would do a commercial deal with us to say over the next 10 years, we would like to purchase, 100,000 tons of CO2 credits. So then we would go away and figure out how to develop that and how to service that through the facilities that we have operating or through facilities that we would like to build. And so that's sort of the deals that we would do with like a private company.
I think Ken had a couple cents.
Or do I? Correct me if I'm wrong, Leslie, but I don't think it's overly regulated at this point. I think it's kind of the wild, wild west. And there's a lot of questions around, okay, are these legitimate carbon abatement credits or not? Because you have to look at the entire life cycle of a technology to understand whether or not it's truly, what the carbon intensity of it truly is. Solar is a good example, right? I think California takes the position that the carbon intensity of solar is 0. But if you look at the construction, you look at the operations, you look at the abandonment of the assets, there's significant carbon intensity associated with even solar. So there's a lot of work to be done on that landscape of enforcing the voluntary carbon market to a mandatory carbon market.
So what we do to make to ensure that we can avoid situations that you might have read of, like back in 2021, there was a bit of like a carbon scandal where an organization, I think they were called Vera, the validity of their carbon credits was called into question because they couldn't really prove that they had stored the carbon permanently. So what we do is we use a life cycle assessment approach, and that is spelled out in, I think it's like ISO 14062 is the standard that says like, this is how you shall measure carbon dioxide for permanent, the methodology. And then we apply a verifiable standard, and then we get a third party to do the verification for us, so that then we can show that, this is how much was captured, this is how much is stored permanently. And like Ken was saying, about 10% of the emissions or the carbon dioxide goes towards our like gray emissions. So things that we would carbon dioxide emissions that we would produce through the capture and sequestration. So we account for that through our life cycle assessment, and we don't those are not sold as credits. Like we do not receive credits for we call them the gray emissions that we produce. So just so people understand that there is like, we do follow an international standard, and then we have a third party so that we can show, anyone that we have verified that we've stored the carbon.
Great. Next question.
Nobody?
Feel free in the room to just raise your hand. We'll throw you the mic. Let's get a mic. Hold on 1 second so folks can hear you. Here I go. Please come forward and your name and where you're from.
Yeah, I'm Anna. I'm from here, from East Bakersfield, born and raised. I just wanted to follow up real quick. Who's the third party that you go through, or are there multiple third parties that you go through?
Oh, there we go. I'm in my steps.
Thank you, Nicole.
Yeah, so we use you might have heard of them, DNV, Det Norske Veritas. So they're a Norwegian company that works globally, and they do all kinds of like auditing, management system work. And so we use them because they are a certified auditor of our process to say, and then they would verify. And I've used them on actually like a number of different projects where they would do anything from like management system work to auditing. So they have a reputation that they would never do anything to threaten that reputation, because this is like their bread and butter of being this really trusted third party verifier of like all sorts of things. They work in like the auto industry and maritime transportation, and now they've looked at, okay, how do we turn this into a business for carbon storage? Yeah.
Thank you for your question.
This one's kind of loaded. How does the permanent storage affect the carbon cycle? Obviously, due to our industrial processes, we have far more CO2 in the atmosphere than is ideal for humans and animals. However, is there a way to recover the CO2? And then some more. Carbon is finite, but there is a cycle much like the water cycle. The cycle is currently unbalanced with storage places, including oceans and the atmospheres, which is not ideal for most forms of life that have developed on Earth, but permanently storing in rock also seems kind of short-sighted.
Right, Kennedy.
Can you repeat the first
Yes.
sentence? Because I think that was the question, was the first sentence.
So how does the permanent storage affect the carbon cycle?
Okay. So the permanent storage is exactly what it means, right? It's permanent storage. So Leslie mentioned 800 meters is the minimum depth where we're going to be storing CO2. And, we're going much deeper than that. If you look at the Carbon TerraVault application, so we're talking 5,000, 6,000, 7,000 foot storage and potentially even deeper. There's several reasons for that. One of them is the security, right? There's multiple very thick sealing layers between the surface and that storage. So the farther you distance yourself from any potential groundwater sources, obviously the better. But the intent here and the execution is to have it's permanent. It's not going to be a part of the carbon cycle in the atmosphere or at the surface any longer. It's going to be permanently stored underground. Leslie mentioned the project in Iceland. It's actually ideal for storage in ultramafic rocks. It's almost immediate geologic time. It is immediate mineralization. So within 2 to 3 years, that CO2 is rock. It's not going anywhere. It's permanent rock. We don't have that luxury in most of our reservoirs here, but it will be permanently stored. Depleted oil and gas reservoirs have held oil and natural gas in place for millions of years. And we expect the same life with CO2 storage.
Wonderful. Next question.
Is there a comparison study between this DAC system and biological carbon sinks like bogs, rainforests, other natural forests? Comparison of water consumption, energy, land and land acreage, etc. Lovely.
I'm sure there is a study. I mean, I'm sure there's multiple studies. I guess like just off the top of my head, I don't like comparing the two because I don't want you to think that somehow like one is better than the other. I guess the one advantage with DAC is that you can look, you can actually show where the carbon is stored. It's stored underground and you can quantify it. It can be more difficult when you're looking at nature-based solutions, which is, you know, like afforestation or looking at like peat bogs and things like that. I think they all have a role. It kind of depends on what you want from it. If it's beauty and, you know, like having more nature, then you might want to go with a nature-based solution. If you actually want to generate the credits to get the credit under, you know, the income tax code, and you want to have like a verifiable way because you've set net zero targets, then you might want to look at direct air capture. But I think they all have a role. In terms of the effectiveness, I'm sure there's lots of studies that you could Google off the top of my head. I don't know like the kind of the direct comparison. There are, you know, inputs for a direct air capture facility because it is an industrial facility. You know, you need electricity, preferably through a renewable power source. You need a source of heat or the electricity to generate the heat, to make steam, to release the CO2. And you need an ability to store the CO2. And so that it becomes more of a mechanical versus a natural solution.
Let's look at 3 more questions, kind of more different variety.
They're pretty much all.
Well,
Yeah.
they keep going.
Okay.
Let's do 3 more.
Okay. How
Oh,
long?
oh. We'll do one here and then we'll do one right there. Thank you.
How long is DAC Hub expected to be operational?
You know, it can be operational for as long as the facility works. It's just like any other industrial facility. As long as you take care of the pots and pans, then it can go in perpetuity. And as long as you have the ability to store. I think right now, like the design life is like 12 years, but that doesn't mean that somehow it breaks apart in 12 years. I think that's just what you put on in terms of like to have an investment time frame. But I think we use 12 years because that's sort of like how we understand the carbon credit market that is right now generated under the tax code. I think it's for 12 years. But like I said, like you can honestly, like you could, as long as you're taking care of the facility, like you know that there's refineries that were designed like 100 years ago. They probably had like a 30-year lifespan, but as long as you're designing them and taking care of them through regular operations and maintenance, they last.
All right, live question here. There you go.
I guess to kind of change the topic a little bit, going back to community engagement. I guess I want to hear a little bit more as to how different communities are going to be engaged, what types of either surveying or information is going to be released to different communities, as well as if this information and community meetings are going to be available in different languages, because we do have a lot of community members that don't speak English.
Yes, yes, and yes, and I hope you become part of the consortium, Norma.
Again, to reiterate, yes, yes, and yes. So what our plan is to roll out a couple of different levels of community engagement. Obviously, one is understanding what this project is and ensuring that when we're providing education, it's at a level that's understandable and digestible to communities and in the multiple languages that are needed. So I'm not a techie myself, so I appreciated the vacuum reference, myself. But again, really making sure that when we're going out, we're doing a good job of helping people to understand what this project is. We're going to be developing a community advisory group. to help drive the community benefits planning process. And again, that's going to be a group that is selected and engaged from the communities that are going to be directly affected. So there are multiple layers of how we are going to be engaging with community. Again, this is a 24-month process that we are engaging in, and it is all planning. So it is an opportunity to really sit down and work with a company that is very open to saying, what are the things that need to be part of this community benefits plan as we start thinking about engaging in an agreement down the road. So
And we're going door to door. We're going door to door, knocking on doors. Our company's already knocked on over 300 doors out in the West Kern. We're building model science fair projects. We're so many different layers that we're not doing weeknights. Like we're not gonna ask you community to come out at 7 p.m., right? We're gonna go to community. That's one of the priorities of this group. Go work communities, childcare, stipends. You want to come and give us advice? We want advice. We're gonna help pay you for your time, and we're gonna have some childcare available and some food available. It's a whole holistic approach to community engagement, right? Okay. One more question? Let's do one more question. Oh, Earl has a question. Okay. We'll go Earl and then one more online, and then Stephen Gomez has a remark, and then we'll close.
Hi, this is Earl Parsons with the Kern Community College District. How does this project differ from other projects that are happening in Arkansas or Texas or the Mammoth project that you mentioned earlier?
How would it be different? So say for like the Louisiana project that we are involved in, that one has funding to actually get to construction. So it's going at, a slightly different pace. We did receive our funding March 27th. So I think it's just a level of technical requirements that are just like one step above, and that we're not just doing the planning, we're doing the planning plus now we're going to be executing and constructing in Southwest Louisiana. In terms of difference, like obviously different issues and different needs in terms of the community benefits planning, different, workforce, similar in the sense of like, it is an energy area as well, like the Gulf Coast, lots of offshore oil and gas development. They have lots of LNG development kind of going on, and lots of environmental justice issues that have been, experienced by disinvested communities in that area as a result of, say, like, sort of robust petrochemical and oil and gas development that has not always been, I don't know, it seems very odd the way they've zoned it, like so close to communities. So it's just like, it's a different level of acceptance for industrial facilities in some areas of Southwest Louisiana.